Good evening, friends. Today's evening topic is entanglement. In this entanglement, we will define interaction or discover the nature of interaction, and also we will discover the nature of collapse. Cameraman, next time marker should be changed, huh, Rima? Okay. So now suppose I have two particles. P1 and P2. I should represent it with some type of denoted letter, so that suppose this is plus up spin, this is downward spin particle. Okay. Now how interaction will take place? How interaction will take place? A pulse of light as photon may go from this particle P1 to this particle P2. This position, now this position of photon, then this position of photon. This is photon pulse and distance is very large. Okay. What may happen on reaching this photon of light, on reaching this particle P? It may and may not interact. The particle may not respond. Photon may pass it, reflect in some other direction. Any physical process may take place. Okay. By the time, why this particle P1, I am showing this is particle now. Why this particle P1 is sending a photon? This may also send photon, this particle also. No. And why only one photon will be sent? Multiple photons over a time period may be sent from both sides. So ultimately between particle P1 and P2, multiple exchanges and continuous exchanges of photons. Ultimately, these two particles P1 and P2 will form a standing wave. Now these particles along with this region, of course some surrounding region, will have a 3D standing wave. 3D standing wave where every point will be in some type of coordinated movement of particle or field, whatever, because at every point something is changing. So coordinated changes will take place at every point. Okay. So this is the nature of interaction. Although we have started from particle with constant spin, upward spin or downward spin. Yeah. Okay. Upward spin or downward spin, for example. No. But when these two particles form a standing wave in this region, then constantly state of, these are not pure particles now. They may have some particle nature, some node nature. Like in standing wave, we have two nodes and there is string, moving string. No? They may have some node nature, but these are not true particles. Okay? And spins up and down are not fully defined. They are constantly changing. They are constantly changing. Of course, there is coordination at every point. So there is net coordination between stream points also. Okay? Stream points also. This is Bohr model. This is closer to Bohr model. If you think interaction in terms of Einstein model, up spin and this is down spin. If you think these two particles in terms of Einstein model, then what is happening is that particle is fixed, have definite spin here and here, up and down. You are observing the particle and you find it is up spin. Before observation by observer 1, we don't know spin. But when you are observing, you get spin up. But you are disturbing, so a extra signal second, as a traveling wave pulse from here travels with the speed of light c, something like that here, and this photon will reach here. This photon will reach here after traveling a heavy distance, so it will take some time, and when whatever may be the spin, the information it will give and spin will be downward, you will observe. Okay, it will change the spin according to the spin of this particle. Okay, this is Einstein model, but it is not instantaneous. But here it is assumed that photon traveling from this will at any cost will interact with this. As far as interaction period between these two particles is concerned, as far as interaction period between these two particles is concerned, interaction period is very, very small. Most of the time, particles have either this spin or this spin. Interaction period is only when pulse interact with this. Okay? So on an average, although decision result of observation decide the result of second observation in its future, decide the future of second observation, but it is not instantaneous. Also, if you leave this interaction time here, that is here, if you leave this interaction time, for example, then almost there is no interaction. Almost there is no interaction. And if there is no interaction, for example, particle 1, particle 2. By photon, you decide, you know the spin. Okay. Now it sends a singular. Distance is very long. In that period, spin of this particle, okay, it is not between traveling of this photon. Both photons have no interaction. Both photons have no interaction. Okay, both photons have no interaction most of the time. So true nature of interaction is, and generality I am showing is that whatever signal is given, it may not interact. But in this model, when traveling waves ultimately ultimately form an standing wave or a closed system, then energy then all these particles are in some coordinated way are changing. Of course, nature of this change is just in coordination with this change, because between every point coordination is there. Okay, a new system is also formed. So original particles are not like that. They are a new type of system, and of course properties are not fixed like that. And since continuous exchange of energy in the form of opposite waves, which are making a standing wave, is being exchanged, in a standing wave what happens? There are two waves. One is moving in this direction, in this direction. Okay, but in standing wave, continuous exchange of energy is taking place. Okay, continuous exchange of energy taking place, and there is coordination. So continuously states of this whatever particle remains or nature of particle remains, state is always changing continuously. So when you make an observation, and disturb the system, then only a fixed state will be reached. Otherwise, spin will be, these two particles will be something like that, these two particles spins are in constant rotation. Remark, cameraman, just see, I'm coming in 5 minutes only. Huh? Okay. So I'm coming in 5 minutes. I will take
लड़कियां गई थी जिन्होंने वीडियो बनाया था उसको डिलीट करें, और जब तक डिलीट नहीं करेंगी तब तक उसको बंधक बनाए रखेंगे, उसको बाहर नहीं जाने। 26 साल की बिटिया है, 25-26 साल की बिटिया जो 1-1.5 साल से यहाँ वकालत कर रही थी, उसके साथ आए थे किसी ने आज हम जो अपने भाइयों के साथ एशिया की सबसे बड़ी बात कही जाती है, उसके साथ ऐसा है। कैसे तो डॉक्टर बचाए और डॉक्टर
वो मर गई जो वकील की लड़की।
लो okay.
हाँ ठीक है।
So that means it is something like that. These two particles are connected with some type of solid rod, and spin is constantly changing. Okay. After this moment, it will be something like that. Okay. But these are extreme positions. Okay. Spins are continuously changing. Okay. So on an average, you cannot say that what is there, spin is there. Spin is decided only when you observe. This system, observer 1, observer 2, when they observe, then only this system superposition will be disturbed by this traveling photon, by this traveling wave, and this superposition will break. It will break accordingly observer 1 and observer 2, how they are breaking the system. Of course they are using a traveling photon, but how they are breaking, they will get their result. Okay. Now mechanism is something like that. Now we have completed the interaction portion. What is the meaning of interaction in terms of Bohr model? Okay. Now I am focusing myself on collapse. Okay. How entanglement formed by this way is collapsed. Okay. So suppose for collapse I want to have something like a roller, horizontal roller, solid roller. Okay. And now it is fixed on this axis so that it can rotate. This roller is of not very ideal material but natural material which is available in our universe. Okay. and it is very long. Suppose it is infinitely long, for example, for our purposes. Huh? And it is at rest. This roller is at rest. Okay. Now somehow giving some torque. Of course, we cannot touch it at infinite quite simultaneously. So that for most symmetrical way, we touch it at some point. We give torque at some point. Okay. We give torque at some point. We start giving torque at some point. This torque is a disturbance. Okay. Suppose we are giving this disturbance at start giving torque disturbance at E0. Okay, at this point, finite point, and there are infinite number of points in this roller. Okay, what you will see that where you have started, where at this point you are giving energy of torque. Okay, but that energy will not move each point of this roller instantaneously. Will not move each point of this roller instantaneously. Suppose I have a small roller. And you give a torque. Okay. Then you will find that for all observation purposes, that every point on this roller move with some angular velocity omega. But now this is very infinite roller, and you are giving a finite torque at some point. It will act as a disturbance. Immediately each and every point will not move according to some omega, desired omega. Okay. What happens? You are giving torque at this point. Disturbances will travel according to wave speed in this material. A traveling wave will be generated. A traveling wave will be generated in this medium. Okay, and you are giving energy at this point. Energy will travel according to the speed of wave in the material. It will reach here. Energy may be lost to the environment also, and it may be reflected also. Ultimately, after giving enough energy, you will get finally some desired omega, because now every point will move with velocity omega in this dynamic equilibrium stage. How this dynamic equilibrium is achieved? These traveling waves actually interacted, and by their interaction only, each point you are giving continuous energy. But after some time you will see that there may be some energy leakages, but if environment is if speed is reached, then environment may be neglected and you will stop giving torque. But how this uniform omega is reached for this heavy rod, it will take time. And how it is reached? Disturbance starting as a traveling wave will be reflected, and all these disturbances, traveling wave disturbances, actually will change the whole system into a coordinated system, which every point will move according to omega. Okay, this omega, this moving of rod in a coordinated way at every point, is actually result of superposition of these disturbances, that is interference of these disturbances, and these disturbances actually are forming an standing wave, So in standing wave, so a moving a moving, now I am elaborating, I am coming to collapse. So a moving infinite rod, for example, na, with some omega is actually a result of an establishment of an standing wave. Okay. Now drawing is not very good, but you now I am saying that at these two ends, suppose this roller has a bead ring in just up before moving, and it has bead ring just in anti-symmetric way here. Okay. Now equilibrium, dynamic equilibrium reached, standing wave has been formed, so it will, every point will be moving with some omega angular velocity. Okay. Okay, cameraman. Okay, cameraman. Now what will happen? Now this is particle, this bead is particle, it represents particle P1 and this particle P2. Okay. What is our particle? I will define. But see, now this system we have some kind of breaks, some kind of symmetrical wave break at 2 points. This system we have some point of 2 break systems. Okay, 2 break systems. Break B1 is known as observer B1 and break B2 is observer B2. Okay, they actually start the observation, that is start the system of break here and here simultaneously. Okay, distance is infinite, I am not taking this, but once you started the break, you are started the observation process, you are sending a traveling wave, you are sending a traveling disturbance in this standing wave, in this rotating thing, in this rotating, what is this? In this rotating roller, which is a standing wave, you are sending a disturbance observation in the form of breaks symmetrically, and it will take, for example, to stop the roll, for example, it takes 1 second. It will also take here 1 second. Okay. Okay, cameraman. What may happen is that ultimately roller will be stopped. Okay, roller will be stopped, but you will find that break actually targets a particular point. Brakes actually targets a particular point. Okay, brakes actually targets a particular point. What you will find that when the system stops, you have this bead particle here just up, and here you have just particle here. Okay, particle here. But within 1 second, what will happen? What will happen within 1 second? What will happen? Since you are disturbing this system by a traveling wave, by a traveling wave, then disturbance will travel in this material as a traveling wave. Okay. Similarly, disturbance will travel from here as a traveling wave from this observation. From this observation. Okay. Both will travel with the material speed. With the material speed in opposite direction, in a symmetrical way. Okay. But these 2 points, for example, which are part of a standing wave system and are some type of coordination, these 2 points, suppose these 2 points are moving just in opposite direction. Okay. Opposite direction, and disturbance just before it causes these 2 points move in disturbance, and just before it there is another point, and disturbance just increases further the distance between 2 points. Distance between 2 points just it reached, so that collapse occurs symmetrically. Collapse occurs symmetrically, and this superposition state is disturbed, and you will see a middle portion, and you will see 2 stopped portions, 2 stopped portions of equal length and equal structure. Of course, one bead position is here, other bead position will be just opposite. Just opposite. Both processes will take 1 second. 1 second. Okay. Distance between these 2 particles are infinite. No signal. Up to 1 second. Up to 1 second. Up to 1 second. When break happens, till this point no signal. Actually, from here to here have to be reached. Have to be reached. At collapse, a signal may release, or for example, a signal is coming in 1 second to this point, in 1 second to this point, but here collapse occurs. Signal as a traveling wave is just here, just here. No distance needs to be traveled by the signal, infinite distance, and you will see collapse just in 1 second. Just in 1 second, simultaneously. This is the collapse mechanism. This is the collapse mechanism. And these particles, these systems are at rest, but they are surrounded with their gravitational field. They are forming a standing wave. It is entanglement system 3rd. It is this particle surrounded by its field, entanglement system 1, entanglement system 3. Okay. So collapse of this entanglement system takes place instantaneously on both points. If breaks here, because you will apply the brake on this rotating mill in a rotating cylinder at some arbitrary time. So position of bead may be at different location in just anti-symmetric way. Okay, but next collapse may happen, so that this portion in next experiment, what will happen? Bead is at lower position with similar collapse, and bead is at upper position with similar collapse. Okay, cameraman. But suppose break nature is so that ultimately bead bead stops here. Bead stops here, where the bead actually touch the brake during rotation. There it stops. It stops. It stops, and brake not only touch here, touch also at just opposite point. Just opposite point. Na some time of system, so that only two results are possible, either this or this, or this or this. Na so this is the way we get both results are instantaneous. This may happen at 1 second exactly, it will also take 1 second exactly in theory. In practice it may happen at 0.9 second. Once it is decided, then it will naturally happen at 0.9 second or 1 second, but distance between these 2 points is infinite second long. You may comparing to this distance, it is instantaneous. So once Alice decided the system, Alice will know Bob has opposite spin instantaneously. You can model this also. You can, Rima, cameraman, you can model this also. This is particle P1, this is particle P2. They are in superposition. But this superposition will take time. Photon will come, multiple photons will exchange, and ultimately superposition will take place. Superposition time, so there is interaction time. Superposition between these two particles will not be instantaneous. Okay, it will take time. Interaction type is time t. It is outer limit, because when you are observing these two particles, there already interactions are occurring, although interference has not been reached. So this is the outer limit, interaction time. This is known as entanglement time. Okay, cameraman. And at this position, so after interaction is complete, and interaction will complete at entanglement time E. Okay. After that, what will be the spin? Spin at this point will be a function of time. Because it is rotating. L is rotating. Na? Function of time and position. Spin at this point will be time and position. Okay, cameraman. What is time here? Time is nothing but it starts from t equal to what is entanglement time plus t dash. There is a small amount of entanglement t dash. Okay, this is t. Okay, cameraman.
ठीक है.
What it will give? Position of direction of L from this central position. So it will give theta t. Okay. For this point you can have x equal to 0. Okay. At some point you will get what? Theta t. But what is spin here? At x equal to infinity, it is infinite length, and same time it will be just angle difference is 180 degree. So it will be 180 degree plus plus theta t. Okay, what is theta t? Theta t is nothing but spin at 0 time t. So what you are seeing in this case is spin equation can be represented, general spin equation, infinity time t is equal to pi 180 degree pi plus spin at what? 0 time t. This is a spin equation. Okay, cameraman.
ठीक है, थैंक यू,
Now
थैंक यू वेरी मच।
thank you Rima.
अंदर भी,
So
इसी के अंदर है।
कैमरे पे कोई आया था?
कोई
हाँ?
था, देख नहीं पाए, कोई था लेकिन
तो नाम लेना चाहिए था ना.
शो नहीं कर रहा था।
Okay, so this is the how we can model and we can understand instantaneous collapse, and we also find that two particles, howsoever they are small, since they are connected with some general graviton structure, because universe gravity is everywhere, gravitational structure, so any 2 points in the universe can entangle, or if 2 points are actually two sets of informations, then they may get entangled anytime. They may get entangled, but of course entanglement will take some time. And this time of entanglement depends on the whether interaction process is already running, or interaction process between these two particles starts just only when you are when you are analyzing the interaction time. If it starts, but you have to take maximum time, so that maximum time can only be that maximum interaction time is nothing but physical distance between these two space points divided by speed of light. Of course, if these 2 points are on earth and some kilometers apart, so there will be no gravitational effect, but at the level of universe you have to suitably adjust the time calculation. No, so this is the maximum entanglement time. However, entanglement is actually also taking place inside the atom, between two spinning electrons. Now, before you observe, both electrons are in both spin, or you can say spin is not decided. And here, instead of two observers, a single observer will create two exactly same systems. A single observer, because whatever signal for collapse have to travel for very short time, this signal actually will reach at every point within that short time, because the distance is very small, negligible. Na? So a single break will generate two electrons with opposite spin. A single observer will be needed, and entanglement will be instantaneous. Jai Hind, Jai Bharat, Jai Vish. Thank you for watching. And I have some vision problem, and many persons are also see. I add various professors, and I am a lay person. I am a side university person. So I have a great regard and gratitude and love for persons or professionals who add me. And if somebody are watching, and okay, I am trying, I may be making some wild or some making nonsense things, or not making some nonsense observations, but if my videos can generate a debate or can gravitize the quantum mechanics, which great Nobel laureate Mr. Roger Penrose say, we have to gravitize the quantum mechanics. So general relativity provides some kind of structure between mass and gravitational field, a unified structure. Newton's gravity is instantaneous. So these can be achieved by the act of what? Something like standing wave nature. A particle and its associated gravitational field is just something like a standing wave, then structure is instantaneous. Okay, and we are disturbing the instantaneous standing wave structure. So entanglement is nothing but an standing wave structure, and we are disturbing the structure symmetrically, simultaneously, by two observers at two ends, and act of observation is nothing but we are actually disturbing it, but by some kind of traveling wave. We are disturbing an standing wave by traveling wave, and we are disturbing it at 2 points only, and these 2 points have some particle nature or some node like nature, and we are disturbing this standing wave by two traveling waves symmetrically, and disturbance creates collapse symmetrically. Without the actual disturbance or actual traveling wave have to travel or cover the whole length of this standing wave structure. Without the necessity of traveling wave to cover whole region of standing wave, we get symmetrical collapse at both ends, simultaneously, instantaneously. Jai Hind, Jai Bharat, Jai Vish. That mathematics predicts. I am trying to give physical sense. We are trying to give us some kind of physical model for the existing mathematical model of quantum mechanics, that is entanglement. Jai Hind, Jai Bharat, Jai Vish. Thank you, sir. Jai Vish also, Jai World also. Thanks a lot, sir.